So moving on to Chapter 9, Topics in Analytic Trigonometry. First lesson is on circles and parabolas. So talking about circles and parabolas, we need to address what are called conic sections. So conic sections are four shapes that you can get on your graph whenever you graph, an equation in an XY plane. And we call them conic sections because you get all four shapes whenever you take cross sections of a cone. So you can see right here, if we have this this cone, and we've got this green plane going through the cone, then it creates a circle, which you can see right there in green. Now, if we take that same plane but tilt it on a side, like tilt it sideways, then that cross section that it makes through the cone is going to be an ellipse, which is another word for oval. Okay. Then you've also got a cross section. If you take it through the side of the cone towards the bottom diagonally, then it gives you a parabola shape, which we are familiar with. When you graph y equals x squared, you get a parabola. And then a new one probably for most of you would be a hyperbola. So if we did a cross section going straight down to the top of one cone and to the bottom of the other, then it's going to give us a parabola, which seems similar to a hyperbola, which seems similar to a parabola because it's got essentially looks like a parabola going upwards and a parabola going downwards, but it's not exactly a parabola. So once we get to that, we'll explain more about a parabola. But today we're just going to be talking about the circle and the parabola. We'll talk about ellipse and hyperbola a little bit later on in another lesson. Okay, so first thing we'll talk about is finding the standard equation of a circle. So the form for the standard equation of a circle is x minus h squared plus y minus k squared equals r squared, where hk is the center of the circle. So the center of the circle is at the point hk, and then your radius of your circle is r. All right. So right here we're given the point 1,4, and we're set. It tells us that point is on the circle, and the center of the circle is at -2, -3, and they want us to write the standard form of the equation of the circle. So if we just drew a little sketch to get an idea of our points, the point 1,4. So over 1 up 4 would be, depending on where our graph sets right here. So over 1 up 4 would be somewhere around in there. And then -2, -3. See, our circle wouldn't be right centered right there. Let's put these points on the graph. Let's do it this way. So 1,4 would be over 1 up 4 somewhere in here. And then -2, -3 would be somewhere down here. And that's the center. So this point on the circle, so we go somewhere around it like this, right? Okay, so what we want to find we need to know the center and the radius in order to write the equation. So our radius is the distance from one of those points to the other. Okay, so what we can do to find the distance is use the distance formula, which is essentially the Pythagorean theorem. So you can think of it this way: how far, if I made this into a right triangle, what would those two lines that I just drew, how long would they be? So to go over from -2 to 1 would be 3, and then to go up from -3 to 4 would be 7, right? So to find the radius, r squared, right, if we call this your radius r squared equals 3 squared plus 7 squared using the Pythagorean theorem. So r squared is going to equal 9 plus 49. R squared equals 58. All right, so we could, of course, take the square root to find the radius, but we don't need the radius to write the equation. We just need the radius squared, which we found. R squared is 58. So we can plug 58 in right there, and we can go ahead and write our equation because we know HK is our center, right? So our radius, our R squared is 58, and our center is at the point -2, -3. So we can just write those into the formula. So we'll say x minus h is -2, so it's at minus -2 makes it +2 squared, and then plus y minus k, which is -3, so +3 squared, equals r squared, when r squared is 58. Okay, of course, you could take the square root of 58 to find the radius, and then when you plug it back in, you'll just have to square it to get 58. But once I solve for r squared, I know I'm going to use r squared to write the equation, so there's no need to take the square root, all right, to find the radius, because we need the radius squared. All right, so there's our answer. That's the equation of that circle, and that's how you do it. So you guys try this one, and I'll go over it. So there's our drawing from our center to a point that's on the circle, and we count the distance over as 2 to go from 1 to 3 on the x-axis, and then to go from 0 to 7 on the y-axis is 7. So we use the values 2 and 7 in Pythagorean theorem to find r squared. We get r squared as 53, and then of course our center is at 3, 7, so that we can plug those into our equation. All you need to know is the center of the circle and the radius. So we plug them in, x minus 3 squared plus y minus 7 squared equals the radius squared, which is 53. All right, let's move on and look at how do you sketch a circle in general form. So right here, this is essentially, if you got rid of all the parentheses from standard form, if you FOILed everything out, multiplied it, this is what it would look like. So what we want to do is sketch this. Well, in order to sketch it, we need to change it from the general form that it's in right now back to the standard form that we're used to seeing, like in example 1. So in order to do that, you've got to use completing the square. So first thing we're going to do is move the minus 6 over to the other side. So we're going to make it equal -6. Move the 6 over the constant number. Okay, now what you're going to do is you're going to complete the square for the x's and complete the square for the y's. So over here, remember when you complete the square, you're going to take half of the number in front of x and square it. Okay, and that's what we're going to add in. So -6, half of that would be -3, and then -3 times itself would be 9. So I'm going to add in 9. Now, of course, if I add 9 to that side, I need to add 9 to the other side in order to make sure I don't change the value of one side of the equation without changing the other side. Now, I'm going to do the same thing for y. So I'm going to add y squared minus 2y, but I'm going to take half of the number in front of the y, which is -2. So -1 is half of -2, and square it. -1 times itself is positive. So I'm going to add 1, so then I need to add 1 to the other side also. All right, so now you're going to essentially factor each of those 3 trinomials. Of course, if we factor x squared minus 6x plus 9, well, multiplies to be 9 and adds up to 6, it's going to be 3 and 3, right? And then we see it's going to have a minus sign on both. So they're both going to be x minus 3. So I can just write this as x minus 3 squared, which is the whole idea, right? We want it to look like the standard form from example 1. So we want it to have x minus something, x minus h squared, right? And y plus k squared, y minus k squared. So that's the whole idea. That's why we do completing the square, is so we can make it into a binomial square. All right, so same thing for the y. So we're going to add, and then we're going to factor y, what multiplies to be 1 and adds up to 2. Actually 1 and 1. So we're going to have a y and a 1, and it's going to be minus on both. So it'll be y minus 1 squared. And then that's going to equal, we're going to add up these numbers. -6 plus 9 plus 1 is 4. So now we've written the equation in the standard form, and we can graph it because we can identify now the center. The center of the circle is at 3, 1, right? Because you're subtracting 3 and subtracting 1, so that's your HK. And then the radius, remember r squared is the thing on the right, so r squared equals 4. So then you take the square root, r's got to be 2. And normally we would do positive and negative, but it's a radius. It's a distance on a circle, so it can't be a negative number. The radius has to be positive. So there's our center, 3, 1. The radius is a 2, so we can graph it now. Go over 3, up 1. There's the center. Now, if the radius is 2, then we can go out 2 from the center in all directions. So go over 2, go up 2, go left 2, and go down 2. And then do your best to draw as good of a circle around those points as you can. All right, so that's how you would sketch the circle. Of course, if it was given to you in standard form, then you would just have to pull out the center and pull out the radius and graph it. All right, so go ahead and give it a try. Try to change this general form equation into the standard form by completing a square and then graph it. All right, so you need to add the 1 over to the right side, then leave some space to complete your squares. So for x squared plus 4x, you take half of 4, which is 2, and square it, you get 4. So we add on 4 to each side of the equation. Then for y squared plus 4y, same thing. Half of 4 squared is 4, so you add 4 on to y squared plus 4y and add 4 to the other side. Now we'll factor each one of them. X squared plus 4x plus 4 factors into x plus 2 times x plus 2, so we just write it x plus 2 squared. Same thing for y squared plus 4y plus 4. Those factor into y plus 2 squared, and then on the right side, 1, 4, and 4 add up to 9. So you can identify your center as -2, -2, and then r squared equals 9, so your radius has to be 3. Then you can graph your center at -2, -2, and then go out 3, So left and right, and go up 3 and down 3 and put a point, and then connect those to make a circle. All right, moving on, talking about parabolas a little bit. So for parabola, finding the standard equation of a parabola. So standard equation for parabola is a little bit more complicated, and we're going to talk about something with parabolas you might not have talked about before called the focus. All right, so the formula for a parabola, assuming this is a vertical parabola, is x minus h squared equals 4p times y minus k. And right here, h and k is the vertex of the parabola. All right, so hk is your vertex, and then p is the distance that the vertex is from the focus. Okay, so again, I'll say it again, p is however far away your vertex and focus are. All right, so it says find the standard form of the equation of the parabola with a vertex at the origin and a focus at 0, 4. All right, now as far as the formula goes, whenever your focus is at the origin, your vertex is at the origin, your formula becomes much simpler. Okay, so just imagine plugging in 0 for h and k, because if your vertex is the origin is 0, 0. So if you're at the origin, then your equation becomes x squared equals 4py, because h and k are both 0, right? So your equation is much simpler when your vertex is at the origin. One thing also to be aware of is if you have a horizontal parabola. So this equation in blue is if you have a vertical parabola. Okay. Now it's possible to have a horizontal parabola. Okay, horizontal parabolas aren't really functions, but if you had a horizontal parabola, your equation, your x and y's are just going to swap places. So you're going to have y minus h squared equals 4p times x minus k. Oh, sorry, the k and h got to switch also. So you'd have y minus k, because k is always the y coordinate and h is always the x coordinate. Okay, so really you just swap the y minus k and the x minus h, and that makes your parabola then a horizontal parabola like this. And then of course if your vertex is the origin, then it's just going to make it y squared equals 4px. Okay, so your equations become simpler with the origin. So it's important for you to understand which one of these is a vertical parabola and which one's a horizontal parabola, because you need to be able to do both. Alright, so find the standard form of the equation of a parabola with a vertex at the origin and a focus at 0, 4. I'm going to erase this one, so you guys don't erase it from your paper. You don't need it, but I'm going to erase it and give you more room. So we're going to find the standard form. Let's draw this real quick. I've got a vertex at the origin, so just get a little sketch. Vertex at the origin, and the focus is at 0, 4, so over 0, up 4. Okay, so here's what the focus is. The focus is always inside the parabola, so I know when my focus is there, my parabola is going to go up. All right, and the cool thing about a focus is it's what it sounds like. Everything focuses to that one point. So if you could imagine like a parabola being like a satellite dish, and you have all these signals coming into the satellite dish, as they come in, the satellite dish is created in such a way to where everything will come in and bounce off and go to the focus. No matter where it's coming at, it bounces and goes to the focus. Okay, so that's the whole point of a focus, is to collect everything from the parabola. Everything on the parabola focuses to that one point. That's why we call it focus. So what you need to know are you need to know your center, h and k, and you need to know p. Again, p is the distance that the vertex is from the focus, okay, however far that is. So in this situation, p is obviously 4, because your vertex is at 0 and your focus is at 4, so p is 4, and your vertex is 0, 0. So you can plug into this, you can plug into the first equation, or you can plug into the second one. Either way is fine. So all we can do is take the right equation and use it. X squared equals, and we do 4 times p, which is 4 times 4 times y. So x squared equals 16y. So that would be our equation. And of course, if you wanted to solve it to get y by itself, then you just divide by 16. Divide by 16. So y equals 1/16 x squared. So that would be the standard form of the equation for this parabola. Okay? So you guys go ahead and pause it and do this one. Make sure you notice first, is it a horizontal parabola or is it a vertical parabola? And use the proper equation depending on whether it's horizontal parabola or vertical. So I'd sketch a little graph and make sure, because remember your focus is always inside the parabola, right? If you got a vertex right here and the focus was right here, well then you know your parabola goes like this because the focus has to be inside the parabola. All right, so go ahead and give the next one a try and then we'll go over it. So you can see my little sketch over here. One thing that I don't know if I was clear about on the last example is P has to be based off also, is it going on the negative part of the axis or positive part of the axis? So the one that I did up here, because I was going up from the vertex to the focus, P is a positive 4. If it happened to be a parabola going down, and it was going down 4 to the focus, then I would do negative 4 for P. Okay, so that's important to understand, is that P can be positive or negative depending on whether you're going up or down, or if it's horizontal, left and right. So right here on this one, whenever I draw my parabola, the focus is left of the vertex. So since it's to the left, P is going to be a negative number. And it's going to be -2 because obviously -2, 0 is 2 units away from the vertex, which is at the origin. So P is -2 right here because it went left. If it was a parabola opening to the right, then it would be +2. Okay, if the focus is out there at 2, 0, it would be +2. So I just take P, -2, and I plug it into the shorter equation for a horizontal parabola, which was y squared equals 4px. And whenever I plug in -2, I get y squared equals -8x. Now you could solve for y by taking the square root and putting a positive and a negative. Okay, but the book has the answer just left like that, so that's fine with me if that's what the book has. One thing that to kind of keep you from being confused about the equations is I remember that this first one up here, this blue one, is a vertical parabola because the x is what's being squared, right? Which is what I'm used to saying on a vertical parabola, x squared. The other equation that I erased that's in red had the y being squared, which is not what I'm normally going to see. So that reminds me that, okay, that's going to be the parabola that's not normal, the horizontal parabola. All right, so let's go ahead and look at doing another one. But this time the vertex is not centered at the origin. The vertex is at 1, 0, and the focus is at 2, 0. So let's go ahead and plot the points. Vertex at 1, 0, so over 1 up 0, and the focus at 2, 0. So my parabola is going to open to the right. So that means my p-value is going to be either +1 or -1 because they're 1 away. Because it went to the right, it's +1. All right. So I'm going to use now the long equation for a horizontal parabola. That's the one that's going to have y being squared. So we have y minus k squared equals 4p times x minus h. Okay, so we just plug in now the vertex for h and k, and then we plug in our value p that was 1, right? So we got p equals 1, and hk is our vertex, which is 1, 0. All right, so remember k is the y coordinate, so y minus 0 squared equals 4 times p, which is 1, times x minus h. All right, so we got y squared equals 4, sorry, not h, I'll plug in 1. There we go. So I got 4 times x minus 1, so that's 4x minus 4. So you can leave your equation like that, or again, you could take the square root and put a plus minus on it. Either one is fine, okay? So that would be the answer for that. You guys go ahead and try this last one, and then we'll go over it. All right, so on this last one right here, you've got a vertex at -1, 2. So we plot it, and then we plot the focus at -1, 0. So obviously this parabola is going to be going down, which means that p is a negative value, and it's distance of 2 between the vertex and focus, so p is going to be -2. And then of course our vertex is at -1, 2. So we take those and plug them into the vertical parabola formula, x minus h squared equals 4p times y minus k. So when we plug in -1 for h, we get x plus 1 squared. And we plug in p for -2 for p. That gets us -8 when multiplied by 4. and then we plug in 2 for k, so we have y minus 2. Alright, so the book has the answer left like that, x plus 1 squared equals negative 8 times y minus 2. But of course, if you wanted, you could FOIL x plus 1 squared and get x squared plus 2x plus 1. And then distribute over here negative 8y plus 16. And then you could solve it for y and put it in standard form that you're used to seeing a quadratic, y equals, whatever, 2x squared plus 3x minus 5, or whatever it might be. So you could keep going and solve it for y if you wanted to put it in standard form for some reason. But the book has it left like that, and that's fine with me. Let me know if you guys have any questions on this, and some practice problems if you want to practice.